All right, everybody, here we go. Last video, I am going to share my screen with you once again and start talking about limiting reagents or reactants. I hope that you have a good handle on the other two videos before starting into this one because you may get slightly confused. But please, at the very least, go ahead and watch the rest of this so that you have a fighting chance for tomorrow. I will be going over the third page of your test, which is a problem over ammonia and copper oxide. We're going to start right from the beginning and walk through it step by step. So this is a good practice of the entire process. So first things first, I'm going to go ahead and get the equation on here. 2NH3 plus 3 copper oxide yields nitrogen plus 3 copper plus 3 waters. All right, then we are going to write out our molar masses, right? So we've got nitrogen is 14, hydrogen is 1, copper is 64, and oxygen is 16. Next, we find our gram molar masses. So NH3, the gram molar mass is 17 grams per mole. For copper oxide, or no, not 17. Yeah, that's correct. Sorry. 17 for copper oxide. Copper plus oxygen is 80 grams per mole. For nitrogen, it is 28 grams per mole. We could put copper in here, but it's the exact same as the original. It's just the element, so it's the same. Water is 18 grams per mole. Okay, so we've got all that written down. Last step to the beginning before we dig deep in is what is given. In this case, we were given that ammonia is 56 grams. We have 56 grams. And copper oxide, we have 290 grams. So those were our givens. Now we've got three parts to this problem. What is the limiting reactant? How much excess reactant is there? And what is the mass of nitrogen gas in grams that's produced here? So first part is we've got these and we need to find the moles. Find the moles. That's our next step on that step-by-step that I gave you. That step-by-step will be up on the board for the assessment, okay? So next step, find the moles. So let's just go ahead and start with the ammonia. So we've got NH3, and it is going to be 56 grams divided by the gram molecular mass, which is 17 grams per mole, we said. And then that equals 3.35 moles. 3.35 moles. So then we'll find the moles of copper oxide. 290 grams divided by our gram molecular mass of copper oxide, which is 80 grams per mole. And that equals 3.63 when you round. All right, so we found our moles. That was our third step. Now we need to do our mole to mole ratios. So in order to find those, you look back up at the problem. In this case, we are just talking about the ammonia and the copper oxide. So a 2-to-3 ratio, 2 to 3. Do you see we're talking about these two guys right here, 2 to 3. So I'm going to go ahead and put that down here, 2 to 3. The 2 is talking about the ammonia, and the 3 is talking about the copper oxide. Apologize for my poor writing here. All right, now you probably want to just put the 2 that we just found over here over top of each other. You think we should just put one over the other. But here's the deal. Those are what we actually have. But our ratio tells us that we should have 3 times as much copper oxide as and 3 moles of copper oxide and 2 moles of NH3, the ammonia. And that's not the case. Our numbers are off. So we have to figure out which one of them is holding us back here. So a good rule of thumb is just to always choose the smaller of the 2 to use. So in this case, that is ammonia with 3.35 moles. And you will put that over X. You will do your cross multiplying, and you should get 5.03. All right. Now that is the moles of copper oxide. That's what it should be according to the ratio in the reaction. But we can see that there is only 3.63. So we don't have enough copper oxide according to what we should have. So that means copper oxide is the limiting reagent. It's the one holding us back. All right, so that's our answer to the first question. This one is limiting. Now, then we get to move on to the second part of the question, which is how much excess of the other reactant is there. So now they're talking about ammonia. How much excess is there? And in order to figure that out, we have to redo our equation, our mole ratio, and we have to use the other one. We have to figure out how much ammonia is there actually supposed to be. So we use our 3.63 for our copper oxide, and we have to figure out how much ammonia is there actually supposed to be here. And when we do that, we figure out that there should be 2.42 moles of ammonia. So now we have to take this 2.42 and then this 3.35, how much there actually is, and subtract them to find the excess. 3.35 minus 2.42, you should come up with 0.93 moles. And that's of ammonia. Okay? So that is your, oh no, I deleted something. All right, that is your second part of your answer there, okay? That was the second part that you were looking for, was right here, the excess. Last piece to this problem, the mass of nitrogen gas is produced in grams. Now that's what we've been doing on the other problems too, so that shouldn't be something new to you, but let's go ahead and find that. So in order to find the grams of nitrogen that we need, we have to use the moles of the limiting reactant. So we've got to compare our copper oxide now to our nitrogen. Now we're looking at these two, a mole ratio. 3 to 1, right? Do you see that? 3 to 1. So the 3 is the copper oxide, and it is 3.63. That's what we found the moles to be, 3.63. Hopefully you can see where we got that from, just up above. And then we're putting it over X. We're trying to figure out how many moles of nitrogen. Remember, this is nitrogen down here. Okay, and when you do that math, you should get 1.21, and that's moles of nitrogen. Now, again, remember back to my other talks, we wish we could stop there, but we've got to convert it back. We've got to convert it back to grams. So now we use our moles times our grams per mole equation. In this case, we're using 1.21 times our gram per mole ratio for our nitrogen, which was 28 grams per mole if I look up above. And when we do that, we get 33.88 grams. And that is your third and final answer for that problem. So go ahead, look back through the work that we've got here, replay the video. This is how you find limiting reactants here. All right, best of luck. Happy studying.